Hello again, it's Paul Beckwith and Shackleton. It's a little bit cold in this room, so I'm using him as a neck warmer. As you can see, he's not sure he's so happy about it, but because I ran out of little uh, dry food bit kibbles or whatever you call them for him. But he's a good sport. He's a very good sport. So I ran out of time in the last video. Had to kind of rush through the end as I'm talking about Super-Typhoon Goni, which has just hit the Philippines and sent enormously high winds through Manila, through the capital city, and we'll see tremendous destruction, reported, in tomorrow's news on this storm. So I'm going to continue talking about some of the reasons why this super typhoon got so strong, and talk about show Earth null school images, which anybody can access and do to have a sort of try to explain sort of the physical details about this storm, which it is will turn out is definitely in the top three of the strongest hurricane slash typhoon slash cyclones, depending on which part of the world you're in. They're called different things. Cyclone is also the more general term for any low pressure area, where you get the rotation around the low pressure area. And anyway, let's get right to the information. So this is an image of the eye and the storm. Okay, and I was talking about this article, which I'll talk about in more detail because I had to rush through it towards the end of the last video. But first I want to show you from Earth Null School. So if you Google Earth Null School and you click on Earth, you bring up this window, and we're looking at the air, the wind at the surface. Okay, and what you can see here is, the storm has just, this is now, okay? This is the passage of the storm, and we can backtrack, go back 1 day, go back 2 days, go back 3 days, go back 4 days, okay? You can hardly see anything here, and now I'll cycle forward in 3-hour increments. So double arrows is a day or 24 hours. This is 3 hours. So I'm going forward, and you can see the formation of this storm. So this is October 28th at 2 a.m. local time, 0200. Okay, you can, that's 3 hours later, so it's starting to intensify. Okay, and the reason why it's intensifying is that the water is extremely warm under there. Well, how warm? If we go to ocean, sea surface temperature there, you can see the water is the water temperature is almost 30 degrees Celsius. Okay, so let's go back to air. Let's go back here, and we'll just continue cycling through, and you can see the progression of this thing. So remember, it's every jump is 3-hour increments. Now it's starting to significantly intensify, right? The warm water at the surface is acting like rocket fuel, feeding the intensity of this storm. And over 48 hours, it went from, it went up from about 35, 40 knots to 155 knots in 48 hours as it went through. So the ocean heat content was enormous. The sea surface temperature is only one part of that. Of course, the ocean heat content depends on the heat, how much heat there is going through the layer, going deeper and deeper and deeper. So this is the progression of this guy getting stronger and stronger and stronger. You can click on here to get an idea of the wind speeds, and if you enlarge it and click, you can get more accurate information, but I'll just keep going here. So really, really nicely formed eye here, right? The classic shape. And it beelines for this little island of 250,000 people here. So 3-hour increments, there we go, coming right on the southern part of that island and continuing on to where it is now, basically. Okay, well that's a projection into the future. If you keep clicking on, you can go ahead in time. This is the wave height, peak wave, significant wave height. This is now. If we go back in time, you can see, so that look, if you click on this, you can see almost 12 meters, 36-foot high waves here. Okay, you can zoom in on it, you know, and get the reddest area, over 11-meter wave heights. And here we have the wind and surface significant wave height again. Okay, this is the sea surface temperature anomaly. Okay, so the anomaly, so the red area, these areas here, basically the temperatures of this water are 2 to 3 degrees warmer than normal. Okay, let's go back here. I want sea surface temperature anomaly. We looked at sea surface temperature. Here we go. Okay, so you can see here 30.1 Celsius, the purplish areas. These areas here, 29.9 Celsius. The water's super warm all the way in. Recall that anything warmer than 26.5 is going to add fuel to the storm. If the winds are going in different directions at different altitudes, those are called shear winds, and those will weaken or prevent the huge intensity amplification of these storms. This isn't the case here. Okay, no shear winds to break apart this storm. I showed you this, and this is an interesting thing. If I look, so the jet streams are here at 250 millibars. So the jet streams, you know, you can see that the the general upwinds at this level are, you know, not that fast. It's not part of the main jet. We have to go up here to see parts of the main jet. Okay, 200 kilometer hour winds. But here, the actual behavior of this storm has caused very high winds high up. So 170 kilometer an hour. So it's almost like, you know, you can see the effect of this storm right at the, you know, about 11, 12 kilometers high. Hey, stop eating my plant, cat. Yeah, he's annoyed. He wants some more food. If you go up even higher, 70 hexapascals, extremely high, you can see this. What you can see here, let me go back a little bit in time. Okay, so what you can see here is this is where the, hey cat, come on. This is where the storm is at the surface, and you can see at 70, you can see there's outflow of winds. You get so much convection, so much rising air that it's actually impacting the winds, you know, up in the high atmosphere at 70 hexapascal pressure. I mean, this is about 11 kilometers higher typically. 250 millibar. This is, I don't know how high you are here, 20 kilometers. I mean, the effects are even seen in the upper atmosphere. 10 hexapascals, not so much. Okay, so let's go back to some of the, hey cat. Okay, he loves these plants. He thinks it's a jungle. I brought in some plants from outside because it's dropped below freezing, and that'll kill any of my plants in pots that are outside. Any of the, I try to keep my annuals alive all by keeping them inside the house. Some of them, they need the light and they just don't make it anyway. It's not just the cold that kills them outside, it's the lack of light. But anyway, I've just brought them all in, and I had them down on a carpet for 4 or 5 days before I put them up into the sunroom. And the cats all 3 of the cats were underneath these things, hiding. And I lifted up one plant, and like cats scattered every direction. I should have had it on video. But anyway, so I was talking about some of the details in here. So I'm going to go through and talk about the figures. So I've mentioned that Goni has maximum sustained winds at 195 miles per hour, which is 170 knots or 315 kilometers an hour, with gusts exceeding 235 miles per hour, which is 205 knots or 380 kilometers an hour. The landfall is likely the strongest ever recorded on Earth. If not, it's in the top 3. It's tied with Moranti and High End, but it looks like it's, when the numbers come out, it's probably going to be slightly stronger. Minimum central pressure, 876 millibar. Atmospheric pressure is 1,013 millibar, so this is a huge, this is what, a drop of 13%, 15%, which is enormous. Okay, the larger the pressure drop in the eye, the larger the pressure difference to the outside, therefore the higher the winds. Okay, and this is an image, a radar image of it. Okay, let's talk about so I mentioned from Earth Null School, the extremely warm Western Pacific Ocean. Okay, that's exactly where Super-Typhoon Goni and further storms next week, we're going to get some more next week, is tracking. Sea surface temperatures of 30 to 31 are spread across the Philippine Sea, all the way west of the Marianas Trench area and the Philippines. Even warmer, close to 32 Celsius seawaters are present over the southern portions of the Philippine Sea. So here we've got the Philippines, and here we have the temperatures here. This is the scale here, up to 32 Celsius in these small pockets here. Okay, this is about 2 to 3 degrees above average for this time of year. So the exceptionally warm oceans are perfect conditions for these super typhoons to develop. Okay, the ocean heat content values, okay, this is sort of an integration of the heat going down into the water. So it's not just warm sea surface temperatures, it's warm water all the way down. Above 150, and these high values contribute to rapid explosive intensification. So this is a storm movement in 48 hours. So it intensified from 35 knots to 155 knots within a 48-hour period, okay, between 12 UTC Wednesday to 12 UTC Friday. Okay, so 12 UTC Wednesday, universal time coordinate, to here on Friday. So Wednesday to Friday, an increase from 35 knots to 155 knots. Very strong intensification. Okay, infrared satellite images show the compact, dense, and perfectly symmetrical typhoon with a 12 nautical mile diameter eye. Cloud top temperatures low, about maintaining between minus 85 and minus 90 Celsius all the time. This is a sign that convection is very intense because it's very warm up top, very cold up top, very warm below, so you get huge convection. And that supports an extremely violent system. Pinhole eye, okay, but then it underwent an eye wall replacement cycle, and the eye doubled in size after it was completed. Okay, that's also a typical thing that happens as a storm intensifies, part of the life cycle of a storm. And then it reached the peak intensity of 170 knots or 195 miles per hour upon hitting the landfall. Okay, what else can we show? This shows the intensification. This is time, shows the intensification. This is wind speed in knots. Okay, a different scale here, but you can see how, it steps up. Constant, steps up, constant, steps up. Okay, extremely strong, powerful, destructive system. And then it's weakening because of the topography of the islands of the Philippines, and then it's going into the South China Sea, and the water's a bit cooler there, so it should weaken before it impacts on probably Vietnam. Okay, there's very high rains, and here's where it's coming in here, Super-Typhoon Goni, and then as it goes through cooler water, it could reemerge here. These are precipitation, 5-day rainfall totals, 373.5 millimeters, in some regions, okay, extremely high rainfall, and you can go and look at some of the other details, but basically a massive superstorm. Thanks for listening.